Hello friends, welcome to Daring Marine YouTube channel. Today we will be discussing about fuel pump in marine diesel engine and their working types. Okay, fuel pumps. So let's move on to details. The function of fuel pump is to control quantity and timing of fuel injected into combustion space. The function is to maintain or to control quantity and timing of fuel injected into combustion space. Quantity and timing of fuel injected into combustion space, and to provide high fuel pressure required to hydraulically operate fuel injector. Provide high fuel pressure required to hydraulically operate fuel injector. Okay. Function of fuel pump is to control quantity and timing of fuel injected for the combustion space and to provide high fuel pressure required to hydraulically operate fuel injector. That means later early injection will lead to lack of power and damage to engine. We have to need the proper ratio for the fuel to combustion takes place. That means proper injection should be take place. Later early injection will leads to lack of power and damage to engine. Fuel injection, this is done with the help of cam and camshaft. Okay, cams mounted on the camshaft, which is driven by crankshaft, are used to provide fuel pumps, one which operate with provider for each cylinder. Okay, fuel injection is done with the help of cam and camshaft. Cams mounted on the camshaft, it is driven by crankshaft, which are used to operate the fuel pumps, one of which provider for each cylinder. The speed of camshaft is same as the engine speed in the case of 2-stroke and half speed in the case of 4-stroke engine. Okay, the speed of camshaft will be same as the speed of engine in the case of 2-stroke and half speed in the case of 4-stroke engine. Okay, fuel injection is done with the help of cam and camshaft, and cams are mounted on the camshaft, which is driven by crankshaft. Cams mounted on camshaft are driven by crankshaft and used to operate fuel pump, one of which is provided for each cylinder, and speed of camshaft will be same when compared to 2-stroke engine speed and half speed when compared to the 4-stroke engine speed. Okay, basic working principle of fuel pump. Fuel pump's basic working principle is, as the cam rotates, it operates a spring loaded ram. Okay, as the cam rotates, it operates a spring loaded ram, that is plunger, which will move up and down in cylinder or in the barrel. Okay, as cam rotates, it will operate a spring loaded ram or plunger, which moves up and down in barrel. The plunger moves up the barrel, and the pressure of the fuel in the barrel above the plunger rises very quickly. Okay, the pressure of fuel that is located on top of the barrel or the plunger will rises very quickly. The high pressure fuel then opens the fuel valve or fuel injector and spread into cylinder in tiny droplets known as atomization. Okay, due to this, high pressure fuel then opens the fuel valve or injector and spread into cylinder into tiny droplets known as atomization. Okay, it is important to note that injection only takes place when the plunger is moving up the cam slope. Okay, so we have to know that injection only takes place when the plunger is moving up the cam slope. Basic working principle is easy to remember, means as cam rotates, it operates the spring loaded ram, that means the plunger. As the cam rotates, the plunger also it will rotates, so which will move up and down in the cylinder. Okay, so due to cam rotating, so it will go up and it will go down, depends upon the cam. As the plunger moves of the barrel, the pressure of the fuel that is placed on the top of the that is loaded ram, that is plunger, it will also rise up quickly. The high pressure fuel opens the fuel valve injector and spread into cylinder into tiny droplets as atomization. Okay, we also know that injection only takes place when the plunger is moving up the cam slope, not going down. When the plunger is moving up, only the fuel will get spread, because due to high pressure fuel then opens fuel injector and spread into cylinder into tiny droplets known as atomization. Okay, here we can see, here cam is there, there is plunger or spring loaded ram. So as the cam rises up, the plunger will also moves up through the barrel. As the oil is placed on the top of the barrel, that is spring loaded ram, that is barrel, so the oil also rises up and it will open the fuel injector valve, and finally it comes out, will inject through the nozzle spray as a fine atomization spray. But actually engine fuel pumps are something different, but this is what I said in theoretical as ideal case, but in the theory, in the practical, this is different, because in principle above explained principle will always deliver same amount of fuel, but in reality actual engine fuel injection varies mainly depend upon load, that is variable timing at beginning and end of injection. Okay, so there are two methods used in marine diesel engine. Okay, but here what we say, actual engine that we discuss, that means when the due to rotation of the cam, the spring loaded ram, that is plunger, moves up and down through in the barrel or cylinder. The fuel is placed above the barrel or above the barrel or spring rotor drum. When the cam raises up, the spring rotor valve will move up and fuel is injected and raised with a high pressure, and it will go and open the injection valve, and finally it will come out or through the nozzle and spread through atomization procedure. But in actual engine fuel pumps, they mention that it will deliver same amount of fuel irrespective of load and load through every time. But in reality, the fuel injection varies according to load, because variable injection of variable timing at the beginning and variable timing at the end of injection. So there are two different methods used in Marine diesel engine. So let's see what are they. First one is port controlled helix jerk pump. It is commonly used in manned BMW engine, also known as 4-stroke engine. Okay, it is commonly used in small manned BMW engine. This is port controlled helix jerk pump, and this is also used in 4-stroke engines also. This pump consists of cam operator, cam operator, single acting plunger with a fixed stroke. So this pump consists of a cam operator, single acting plunger, okay, with a fixed stroke, and plunger has a helix machined into it, which also form vertical groove. Now the plunger will be having a helix machined into it, so which form vertical groove, and an annular groove at the base of helix. Okay, the plunger has a helix machined into it, also form vertical groove and an annular groove at the base of helix. Okay, the plunger reciprocates in a barrel and located in pump body, which has spill ports connected to suction side of pump, drilled so that they are above the top of plunger, and a cam is on base circle. Okay, the plunger reciprocates in barrel, that we know that, and located in the pump body, which has spill ports. Okay, connected to suction side of pump, drilled so that they are above top of plunger when the cam is on the base circle. Yes, we decided in such a way that the plunger will be on the top of the cam. Okay, so the plunger is keyed to sleeve which has a gear wheel or pinion machined into it, and plunger is keyed to a sleeve which has gear wheel or pinion machined into it. The pinion measures with a rack which can rotate plunger related to barrel. This rack is connected to the engine cover. Okay, the plunger is keyed to sleeve which has gear wheel or pinion machined into it. The pinion measures with a rack which can rotate the plunger related to barrel. The rack is connected to the engine cover. Okay, the pump barrel will fill up with oil during the downward stroke. You know that the plunge barrel will fill up with oil during downward stroke through suction port, which is uncovered. But during the upward stroke, the plunger covers the suction and spill port. The suction and spill port will be covered, and beginning of injection is constant. Yes, we achieve through this by closing the suction and spill port. We will change the beginning of injection is constant and achieved by fuel pressure rising above spring loader pressure. Spring loader pressure, delivery valve preset pressure. So we achieve by fuel pressure rising will be rises above the spring loader delivery valve preset pressure. The delivery ends when the helical edge uncovers the spill port, as that we see in the figure C. So the delivery ends when the helical edge uncovers spill port, and beginning of injection is initially set at constant. We set the beginning of injection at a constant. It starts with when the top edge of the plunger covers suction port. It starts when the top edge of suction of the plunger covers suction port, and pressure is greater than delivery valve setting. And pressure, if the pressure is greater than delivery valve setting. End of injection is variable and is controlled by a helical edge uncovering the spill port. And end of injection, it is variable and it usually is controlled by a helical edge uncovering the spill port. And this can be varied by moving rack and pinion mechanism, which rotates the plunger and helix. Okay, this can be varied by moving rack and pinion mechanism, which moves the plunger helix. And spill port spills fuel back to suction side. This is, and spill port will spills the fuel back to suction side if it is not properly atomized and all. This is commonly used in pump. Okay, that is port controlled helix jerk pump. Here what they mention is the pump barrel will fill up with oil during the downward stroke through a suction port, which is uncovered, and during the upward stroke the plunger covers suction and spill port. During downward stroke the suction port will open so that oil will come and fill it in it, but during upward stroke the plunger will cover suction and spill port, and during the beginning of injection it will be constant. By we get it constant by fuel pressure rising above spring loader pressure. So delivery valve ends when the helical edge uncovers spill port. When the spill port is also covered with, the delivery valve is finished. Delivery end, and beginning of injection is initially set at a constant. Usually at a constant value is set, and it starts when the top edge of plunger covers suction port, and pressure is greater than delivery valve setting. And if the pressure is greater than delivery valve setting, and end of injection is variable, because end of injection we can variable, and it can be and is controlled by helical uncovering speed port. Like I said, beginning of injection is constant because we maintain it by initial setting constant by top edge of plunger, cover suction port, and pressure is greater than delivery valve setting and all. But end of injection is variable, so we need to control it by helical edge uncovering speed port. This can be varied by moving a rack and pinion mechanism. So by using rack and pinion mechanism, we will control the what we say ejection, end of injection, by rotating the rack and pinion, by moving rack and pinion mechanism, rotates plunger and helix and all. And spill ports spills fuel back to suction side. If there is doesn't go to for the atomization and all, the spill port will spill the fuel back to suction side. And this is the common type used pump. That means port controlled helix jerk pump. This is the common used pump. Here we can see beginning of injection, plunger, suction discharge port, plunger vertical groove and all, effective pump stroke, then helical edge design, end of injection, vertical groove and all. Yeah, this is what some of the basics that we have read in the port control helix jerk pump. Okay, suction and spill control fuel pump. Suction and spill control fuel pump means a plain plunger here reciprocates in a barrel. As a plunger moves up and down, here a plain plunger will reciprocate in barrel as a plunger moves up and down, and two pivotal levers operate the push rod which opens suction and spill port. Here there will be levers, two pivot lever operate the push rod which will open suction and spill port. When a cam follower is on base circle of cam, when cam follower is on the base circle of cam, suction valve will be open and spill valve is closed. When the cam is on the base circle, suction valve is closed and suction valve is open and spill valve is closed. So as plunger moves up the barrel, suction push rod moves downwards and suction valve closes. The injection then started, that is commences, and fuel is delivered via non-return valve to the injector. As plunger continues upwards, spill push rod will open spill valve and pressure above plunger will fall and injection will start. This is what happened. Means as the plunger moves up the barrel, as plunger when the cam is on the base circle, means suction valve is open and spill valve is closed. So it will not, oil will not spill go out. So as the plunger moves up the barrel, slightly when it moves up, suction push rod moves downward. So suction downwards and suction valve slightly closes. It was open during the base circle, but when the plunger moves up and suction push rod moves downward, the suction valve closes. Then injection slowly starts commencing, and fuel is delivered via non-return valve to the injectors. As the plunger, when it continues moving upwards, the spill push rod will open the spill valve and pressure above the plunger will fall and injection will cease. This is what happened in the case of suction and spill control fuel pump. Delivery, spill valve, we can say English there are two lever. Here will be plain plunger, it will reciprocate in the barrel and plunger will move up and down, and two pivotal lever, they will operate the push rod with which opens suction and a spill valve. This is what the picture of a suction and spill control fuel pump. Thank you.